Algebra 1, Lesson 92, Uniform Motion Problems about Equal Distances. So, uniform motion is our distance equals rate times time equations. So, our equations will normally look like this. We'll have distance 1 is equal to rate 1 times time of 1, and then we'll have distance 2 is equal to rate 2 times time of 2, right? And then we'll have to substitute and eliminate through those equations. What we have here is, in these equal distances, is they will tell us that distance 1 is equal to distance 2. What this does when we have equal distances is we don't have to use these two equations. We can set the rate and time equal to each other. So if you think of it in terms of substitution, so this is a little bit easier for your minds, is if I substitute rate 1, time of 1 for distance 1, and then I substitute rate 2, time of 2 for distance 2, I end up with the following equation. I get rate of 1 times time of 1 is equal to rate of 2 times time of 2. All right, so this is the equation we're going to be dealing with when it comes to equal distances. So remember, if you have equal distances in your word problem, rate times time is equal to rate times time. Now, let's go ahead and put this into practice. Let's see here. The members of the girls' club hiked to Lake Ten Killer. I wonder if that's supposed to be Teen Killer, and then they changed it. Just seems like a horror movie trope, you know, like a bunch of teens at a lake, and they get killed by some crazy guy in the woods. Anyways, the members of the girls' club hiked to Lake Teen Killer at 2 miles per hour. Mr. Ali gave them a ride back home at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. How far was it to Lake Ten Killer? So, we see them walking a distance and then driving back the same distance. So we have equal distances. You even draw on a diagram here, distance hiked, distance ridden or rode. So we can use our rate times time equals rate times time equation. So I'll start filling in some information that they tell us from the problem. We'll start off with our base equation too. So we'll have rate of hike times time of hike is going to equal rate of, I'm going to use D, rate of drive times time of drive, right? What's going on with my focus? Okay. Now they tell us that they hiked at a rate of 2 miles per hour. So rate of hike is equal to 2. The drive back was at 12 miles per hour, so rate of drive is equal to 12 miles per hour. And it says that their hiking time was 5 hours longer than their riding time. So we have an equation for time of hiking equals time of driving. Now, time of hiking took longer, so this isn't true. Since this is the shorter time, I have to add 5 to the shorter time. So time of hiking equals time of driving plus 5. That's all they give us. They want us to know the times, and they want to know how far it is to get to the lake. So, let's start substituting. We'll do this in green. So I'm going to take rate of h, substitute that here. So that's going to be 2. I'm going to take time of h. I'm going to substitute this here. So that'll be 2 times td plus 5 equals rate of drive, which I know is 12. Substitute here. 12 times time of drive. So now I have an equation with one unknown. I can substitute and eliminate and solve. But first I have to rewrite. So I distribute to rewrite. I have 2 times time of drive plus 10 equals 12 times time of drive. Now that I'm done rewriting the equation, I'll go ahead and start solving. I want to get all of the unknowns on the same side, so I'll subtract 2 times time of drive. That cancels. I get 10 equals 10 times time of drive. So my time of drive is just equal to 1. TD equals 1. So I've solved for one variable so far. And then I can take this and I can plug this into this right here. So time of hike is equal to 1 plus 5. So time of hike is equal to 6. Solve for two unknowns. Now, the last thing they want to know is they want to know the total distance of the entire drive. And you may be thinking, I don't have an equation for that. Well, we do. Distance equals rate times time. So I can take the distance and I can substitute the time of the drive and the speed of the drive. Or I can substitute time of the hike and the speed of the hike. So if I do distance equals time of hike times rate of hike, then the distance is going to equal 6 times 2, which gives me 12. So the distance is 12 miles. So again, we're still using skills that we know. We know how to rewrite equations. We know how to substitute. We know how to use distributive property and stuff like that. The main information here is this new setup of rate times time equaling rate times time. If you guys have any questions, let me know on Moodle, and I will see you in class.